So now let's look at the hypothesis testing 5, which is the test for independence. So again, the test of independence, we're using the chi-square testing, which is different from the goodness of fit that I mentioned last time. So maybe we can look at the example. So the example is problem 1 from section 2 on discussion worksheet 26. So this problem is testing the relation, if there is relationship between ice cream preference versus the midterm score. So our null hypothesis here is the flavor preference does not affect the midterm. Our alternative hypothesis is does affect. So does not affect basically means that they are independent, or you can write these two events are independent, and our alternative hypothesis will be not independent. And then we just need to look at the what we have from a table of what we have. So we have two events. One is ice cream. We can either favor vanilla or chocolate. Another event is we did well on midterm. So we can either do well or not well. And for each of that, we have like observed value, expected value, observed value, and expected value. So we're given that 15 did well and like vanilla, and 11 did not do well on like vanilla, and did well on like in chocolate, and did well on midterm, and the rest is 14. So just all the information we have, and we can like on top of that we can add the total. So basically calculate each row and column. This is 25, 25, 50, 26, and 24. Okay, so that's all we have after reading the problem. And then we need to solve this problem. How do we solve this problem? We need to fill out the expected value. And how do we calculate the expected value? The formula is for each expected value, for example, this one, it can be determined only by 3 values. The total corresponding to its row, and the total corresponding to its column, and the entire total value. So this one will be calculated by 25 times 26 divided by 50. And this one will be calculated 25, 20 times 26 divided by 50 again. And this will be 24 times 25 divided by 50. And then 24 times 25 divided by 50. And remember, like for chi-square, the R statistic is always defined to be expected minus observed squared, or observed minus expected squared. It doesn't make a difference. Divided by expected. So in this case, we need to like calculate the specific value of this. This is 13. This is 13. 12. And this is 12. So our expected value minus observed will be 13 minus 15 squared divided by 13 plus 12 minus 10 squared divided by 12 plus 13 minus 11 squared divided by 13 plus 12 minus 40 squared divided by 12. And if we calculate out, that is roughly 1.28. So we can calculate our R statistic. And one more important thing is the degree of freedom. The degree of freedom of chi-square of goodness of fit is calculated by the total outcomes minus 1. However, in this case, we are testing for independence. We're not testing of goodness fit. The formula is A minus 1 times B minus 1, where A stands for the total outcome of event A, and B stands for the total outcome of event B. In this case, we only have two possible outcomes, vanilla and chocolate for ice cream flavor, so that's 2, and then we need to minus 1 by the formula. And then for midterm performance, it can be either well or not well. So we also have two possible outcomes. So 2 minus 1 times 2 minus 1 is equal to 1. So our degree of freedom is just 1. So we plug in the degree of freedom and the significance level to the alpha and degree of freedom to the test, and then check our critical value. Or in this case, we're checking the p-value. So if you plug into the online assay, you will get the p-value, which is equal to 0.2579. So what can you conclude? So since we're calculating the p-value, we don't need alpha here. We need our statistic and degree of freedom at the p-value of 0.2578. And then we know that the p-value, our significance level alpha is 0.05, and our p-value is greater than alpha. So we can not reject our null hypothesis and conclude that the ice cream preference and midterm performance is independent, which makes sense. So a short review of how to solve this problem is basically you first need to identify the test is independent by checking if I should am I doing like one event affecting another thing, or if I'm just simply checking the difference between expected and observation. and then you need to like form table to just plug in all the information you have. Remember to calculate the total for column and row, and then you need to find the expected value, which can be calculated by which only needs corresponding row total, column total, and the total, which is 50 here. This three value. And then you can find the R statistic by the formula, and you can find the degree of freedom. So you can plug it in to the chi-square applet to find the p-value. And then last, you want to check if p-value is less than alpha or greater than alpha. If p-value is less than alpha, we can reject our null hypothesis. So we can conclude we should reject or not reject. So that's it for this review.